I have to express this quadratic expression in the completed square form. So I will factorize my 2 out first. And then I will try to make sense of this expression over here. What is the meaning of x squared? It is actually a square, x and x. And then what is the meaning of negative 6x? It is a rectangle, which I have to put it in a square. It needs to fit a square. So let's say the big square is this way. So where will you put your minus 6x? How will you divide your minus 6x into a nicer portion? I try to fit in nicely. So what I can do, maybe I create a length of minus 3 here and minus 3 here. And what is this rectangle's area? Minus 3x. And this rectangle's area is going to be minus 3x. So together, you can make sense that this plus by this, you are going to get the minus 6x here. Okay? Now, and what is this tiny part here? This is the x squared. So I can see I have the x squared and the minus 6x. But this is a big square. And what is the area of this big square? How will you express? What is your side length now? Your side length can be expressed as x minus 3. So the area of this square is going to be x minus 3 squared. But then I have a redundant portion which is not part of my expression. This is my expression. I have my x squared and I have my minus 6x. Do I have that redundant portion here? No. So what you have to do, you have to eliminate that. Eliminate is a minus. And what is the area of the orange? 9. Okay, so that's what I'm going to write into the bracket. It's x minus 3 squared minus 9 plus 11 minus 18 plus 11, and that's it, we are done. Or you can do by differentiation. I know for any quadratic expression, it is going to be in this particular format. There is a turning point at the bottom. So what is the slope at the turning point? It is exactly 0. Slope is 0. So if the slope is 0, how do you write this mathematically? My dy dx is equal to 0. So I'm aiming to find this point here, which is my turning point. So let's take and differentiate. I get 4x minus 12 equal to 0. My x is equal to 3. For that x equal to 3, what is my y value? You take this x, you substitute here. You will end up with a minus 7. Since you have the turning point and you can try to express it in the completed square format. So what am I going to do? I'm going to take this and I'm going to write in the bracket format. Can I do it as x minus 3? Yes. So I try to fit into the format. It's a shortcut, so please make sure you understand the shortcut the right way. And then what I will do, I'll take my y and I will put it here. Now, I need to go and look for my coefficient of x squared, which is a 2 here. So I will take that and I will drop it in front here. Kindly check your expression by a proper expansion. Make sure you get back the 2x squared minus 12x plus 11. Although you are using a shortcut, you don't want to go wrong. Okay, next, I need to find the largest value of the constant k so that the f is a one-on-one function. What is one-on-one function? For one x value, I need to get a unique y value. Why do we do this? You will know in the second part, because you are looking for the inverse function. That is the criteria for the existence of inverse. So what is the best method to make it one-to-one? We need to look at the turning point. Do I already have the turning point? Yes. Where is that? It's here. You see? X equal to 3, y equal to minus 7. Or you can get it from this completed square format over here also. It is 3 comma minus 7. So what I will do with that, I can quickly sketch to make more sense of the expression in the form of a diagram. What is my y-intercept? 11. This one is a positive value. So I'm going to get a happy parabola. Where is my 3 and minus 7? A rough sketch. Maybe I'll just do it like this. This is my 11 y-intercept. My turning point is 3 and minus 7. It looks very symmetrical. I mean, the gap of the x and the y, when you sketch, you make sure you sketch properly. Now, you look at this expression over here, this inequality here. I want the x to be less or equal to k. So, where is my axis of symmetry? My axis of symmetry is here, which is exactly x equal to 3. You need to take the lesser side of your axis of symmetry. Why? Because the question uses the word largest value of the constant k. Okay, we know that we can just cut until here. Maybe my x value could be a 2, but you want the largest value of the k. So if you want the largest value, then you need to cut it symmetrically, where your x is going to be 3. Another way of writing this is x less or equal to 3, therefore your k equal to 3. Do not write k is less or equal to 3. It's a pitfall. This is wrong. Don't do this. Now part 3. For the value of k, find an expression of f inverse. So this is actually giving me a condition. I have restricted my domain. So I made sure it is 1 to 1 now. So the moment it is 1 to 1, I can quickly find the inverse function. So let's do it. So my fx, I'm going to let my fx to be y. What is my y? You take the completed square format. 2x minus 3 squared minus 7. So what is the idea of finding inverse? We switch the x with the y and y with the x. So we change the variable. A simple rearrangement. Will give you this. But you have to ask yourself, you need to make decision of your plus and minus here. Remember, your function and the inverse has to be 1 to 1. Now, is this 1 to 1? Let's say I input a x value. How many possible y value will I get? There is a 2 values here because one is plus, the other one is minus. Imagine I'm getting 3 plus some value here, and that is also equal to y. Or you will do 3 minus something and it's also equal to y. This is for a single x value. For one x value, I'm getting 2y, which is 1 to many. You need to get 1 to 1. So how do you make decision on your sign? Are you going to take plus or are you going to take the minus? A fast way is by checking at your inequality sign here of the domain of the function. It is less. So when it is less, you can directly take the minus. But if you think it doesn't make sense, okay, let's write the answer first. My f inverse x is 3 minus x plus 7 over 2. If you think that, how is that? Just because the domain is less or equal to 3, how can I choose the minus sign? If you are not in agreement with this shortcut, then let's do the concept method. What is the concept like? So I know this is my f and I need to find the domain of my f. What is the domain? X less or equal to 3. So I'm going to take a value to check, and my value is, let's say 2, x equal to 2. I take the 2 and I will put into my function. So if I put a 2 into that, I will end up getting a minus 5. And what is this? This is the range of the function. But then we are doing inverse. So when you do the inverse process, this becomes the domain of your f inverse. So I will try to take the minus 5 and I will put it into this in order to check, will I be taking the plus or minus? If my x value is minus y, I must get the y as 2 for my inverse function. So which one will give me that? Okay, let's do. So minus 5 plus 7 divided by 2. This is exactly 2 divided by 2, which is 1. So will you do 3 minus 1 or will you do 3 plus 1? So this will help you to make the decision. This gives me a 2, whereas this gives me a 5. So where is the 3? This one. This is the cert that I just solved. And I am aiming to get the 2 here. So which sign is that? Of course, the minus. Okay, now let's do the domain of your inverse. So what is my domain of f inverse? Domain of f inverse, it's exactly equal to my range of the function. So you can just see it like this. Domain of your f inverse It's exactly range of your function. So how will you find the range of your function? We have already done here. So you go back and you look at this. In here, what is your lowest y value? My minimum y is equal to minus 7. And my maximum y is approaching infinity. See, anything from minus 7 and then I'm looking upward. So how do you define the range of your function? Y is more equal to minus 7. Therefore, you carry this forward here and you can write. See, range of the function, it's exactly your domain of your inverse. So when you express your domain of inverse, make sure you change the variable to x. X more equal to minus 7. That's your answer. Now, the last part. I have a function g given such. With k now taking the value of 1. So where did I get the k? Where is our k? Let's go back to the question. Okay, it is the domain of my function fx. So I'm going to write here my fx is 2x minus 3 squared minus 7, x less or equal to 1. Okay, the k is taking value of 1. Find the largest value of the constant p, which allows the composite function fg to be formed. Now this is the criteria of existence for composite function. So what is the criteria? You want the range of the g to contain within your domain of f. Another way of saying contain within is subset. What is another way of writing subset? It's inside. So let's find the range of my g. How do you find the range of g? What do I know? I know the domain of my g, x less or equal to p. So to find the range of g, you will take the p value and you substitute into your g. So what will you get? You will get p plus 3. And I know my y will become less or equal. If you can't make sense of this, just draw the x plus 3. Can you draw this x plus 3? It's just a linear line with y-intercept of 3 and a gradient of 1. So let's say this is my 3. And I'm going to get a gradient of 1 there. At this, as an AS level student, you should be able to draw easily. You should be able to get the x-intercept and y-intercept quickly. And this is a minus 3. I'm done. Okay, now, do you know where is the position of your p? You are unsure. So what I'm going to do, I'm going to randomly put it on the positive x-axis. Let's say this is my p value, which is the x. Okay, and where is it on my y? I reflect on the graph. And what is this? This is the y value, which is the p plus 3. So you park it here first. This is your y. Now, what does the domain say? The domain is telling you need to take x less or equal to p. Where is x less or equal to p? It's this side. Less or equal to p. So which part of the graph will you take? Of course, the left hand side. So how do you see this? You just make a line exactly at x equal to p and then you shade the left part of your graph. See, you cannot take the right side of your graph anymore because your domain is on the left hand side. Okay, I hope you can see this, yeah? To make things more clear for you, let me extend the line. So which part am I taking? I'll highlight using green. I'm taking this one. So what is your highest y value here? Isn't it p plus 3? For the defined green part of the graph, the highest y value is p plus 3. And that is why I am putting a less here. Okay, done. I know this is lengthy and let's go to the next part. We are done with the range of the g. Now we need to find the domain of the f. Do I have the domain of the f? Yes, it is already given to me. Okay, and they are saying it has to be less or equal to 1. So what will you do? You should be able to write a statement as p plus 3 equal to 1. P is equal to minus 2. Okay, let's see again. What is range of my p? It is p plus 3. Anything less or equal to p plus 3. What is my domain of the function? X less or equal to 1. Now you are finding for largest value of constant p. So if you want the largest value, you have to equate the p plus 3 to the 1.